Okay. So there's a whole bunch of different things here that we'll look into, but we're starting with lesson 2 here. So that's grade, angle of elevation, and tangent ratio, but there's a lot more to this as well. So I want to first start off with the Pythagorean theorem. So we've talked about this before a couple times. Now we're actually going to be learning it. You might know this already, so it might be a refresher for you, or it might be new to you. We are going to have to kind of accelerate through it, so just bear with me as best you can. But the Pythagorean theorem here is there was a mathematician named Pythagoras who is the one who came up with this. However many years ago that was. I think this is in like BC time, so this is really, really, really old. Make that a little bit bigger. So what we use this for, this is the fancy way of saying, so the Pythagorean theorem is, it's the sum of the squares. I'll show you what this means in a second. On the legs of a right triangle is equal to the square of the hypotenuse. And the hypotenuse is always opposite of the right angle. So I'll show you what this actually means in a second. Give me a chance to write that down. Okay, so this last part here, I'll go into what this means, but this last part, the hypotenuse is always opposite of the right angle. What's the right angle here? What numbers or letters beside it? C. So right here's the right angle, right? When you see this little square, that means it's a right angle triangle. This is 90 degrees, which means this is pure up, and this is pure flat. And so the hypotenuse is always opposite of this. So this side here, the little c, is going to be the hypotenuse. You see how it's opposite of it, right? If you were to draw like a little arrow there, that's how you end up getting there. I would love to spend more time on it, but that's just going to be something you're going to kind of have to memorize. Is that this is how I find the hypotenuse, because you're going to be using this tomorrow for sure, maybe today. So there's a formula we use for this, and just let me write that in a second before you go and add it. That will bigger. Ooh, a little bit too big. Here we go. So here's my formula, which is a squared plus b squared is equal to c squared. So this is a formula you'll be using quite a bit throughout the class. I'm going to explain like what it means though. But what is the a? The a is the length of this side here, right? You see it has the little a there. The b is the length of this side, and the c is the length of the hypotenuse. So you should see that paper that I've handed out to you. So you should see this thing here, right? But technically you just have all 4 of these sheets condensed into one sheet. So a squared plus b squared plus c squared is the Pythagorean theorem. In terms of what's a and what's b, no. So I'm just kind of explaining this. So in terms of what's a and what's b, it doesn't matter. The only thing here that matters is that you have c correctly identified. C is the hypotenuse always. It is always the hypotenuse. It doesn't, like, you could say that this is B, you could say that this is A, it doesn't matter. So let's go into this here. So if you scroll down, you should see this on your page here as well. So this is a triangle I have in here, right? This is the same triangle of it. I have A, I have B, I have C. So remember, it's A squared plus B squared plus C squared. What that basically means is the length of A in this case is 3, right? No, oh no, that's the second sheet I handed out by your coffee mug. Oh. Yeah. So we say how A is 3 here, right? Like we understand where I'm getting 3 from. There's just the 3 little blocks here. So that's 1, that's 2, that's 3. For B is 4. And in this case, C, which is the hypotenuse, they're telling us is 5. So what we use Pythagoras for is basically to find the length of one of the sides of a triangle. So if we don't know one of the lengths, it's like if I didn't tell you like that C was 5 here, you can use this to figure out what the length of that is. And so we know this is kind of true because if you were to square this, which is what these blocks are, right? If I'm looking at C here, it's 5 times 5. There is 25 blocks, right? I'm looking at A, it's 3 and 3, there's 9 here. I'm looking at B, there's 4 and 4, there's 16 here. It's saying A squared, which is 9, plus B squared, which is 16, is equal to C squared, which is 25. That's true, right? 9 plus 16, oh gosh, that's way too small, is equal to 25. That works. This is when I've squared the values. So like I'm hoping that makes. Yeah, I was just counting little squares in there. Yeah, that's where I got the 9 and 16 and 25 from. So like I'm hoping that kind of like I can't spend too much time like on this, but I'm hoping that kind of shows you at least like how it kind of makes some sense. That's why we square it. That's why we take A squared. We take 3 squared, right? That's what this is. 9 is just 3 squared. This is how I got my 3, right? That's the length of the one side. The 16 is just the 4 squared. And the C squared is just 5. So this works. You could, as long as it's a right angle triangle, whatever you put there is going to work. If it's a right angle triangle, this will always work no matter what. You can always use 2 sides to find the length of the third side. As long as you've identified which side is your hypotenuse, which is always C. So like I just have like there's technically a little example on like this third part here down here, but that's kind of just what we showed you there. But again, if you're ever unsure, write the formula down, figure out what C is. It doesn't tell us. It said if this told you this is 3 and this is 4, you didn't know what this is. That's how you'd find it out. You just substitute it in, multiply those exponents, add it together, and then you do something called the square root here. So we'll show you a couple examples here, but you square it and then you take the square root of it. We'll come back to that in a second. We'll come back to this 4th page here later as well. But I want to just go back here. So Pythagoras theorem, that's what that is. It's where we identify the hypotenuse, we substitute the stuff in, and then we work it out. So we're actually going to do a couple quick examples before we come back to that tangent stuff. So go to page 13 on your little booklet there. And there's that first example. So we know this is a right angled triangle because it has a right angle in here. That's the little part I'm highlighting in blue. It's a right angle triangle because it has that in there. So we know that the Pythagoras theorem is going to work. So if I wanted to try and figure out the length of the hypotenuse, first off, it's a right angle triangle. I'm trying to find a side. I know I can use Pythagoras theorem. So I'm going to write my theory in there. So it's A squared plus B squared is equal to C squared. So I write my theorem in there. Oh, we'll get there. We'll get there. Kind of. So first off, what's my hypotenuse here? This line here is called AB. I'll explain why I'm calling this in a second. This one here is called AC. This one here is called. A plus B? We'll get there. We'll get there. So don't worry about the font. Oh. So the reason.
The shape on, like, when it says that you got the hypotenuse, there's a little shape plus b squared.
A squared plus b squared equals c squared. Yeah, it's a 2. Sorry. I don't have a way to write the little like squared very nicely.
Oh, it's the a.
Oh yeah, it's an a. Sorry. Yeah, a squared plus b squared equals c squared. So this thing here. So the reason I've called this line AB is because this is the line between A and B, right? This line's called BC because it's the line between B and C. This line's called AC because it's the line between A and C. So which of these 3 lines is the hypotenuse? AB, right? Because it's opposite of our right angle. So I know that this is, I'm calling this C. The reason I'm calling it C, because it's the hypotenuse, right? Cool. So I've identified that. So write my formula in, identify what the hypotenuse is. Now let's start filling it in. So a squared, it doesn't matter which one of these I put as A, which one I put as B, as long as I figured out what the hypotenuse is. So I'm just going to do the first one I see, which is 3.9. So I do 3.9 squared plus B squared, which is going to be the 2.5 in this case. I should have centimeters in there. So whoops, I've gone too far now. I don't know a numerical value, a number for C. So I'm just going to leave it as it is, C squared. A squared plus B squared plus C squared. Now, a common mistake a lot of people do, I'm going to show you 2 of them. 2 common mistakes people make here. Common mistake number 1, they forget about the square. They just take the 3.9 plus the 2.5.
So it's like,
That's a common mistake 1.
so it's like 15 decimal.
Oh, we'll get there. So the other common mistake people make is they'll put the squared here, right? Yeah, 3.9 squared. Oops. But what they'll do is they'll multiply it by 2.5 squared. We're not multiplying these, we're adding it, right? So that's the other common mistake people make. So it's 3.9 squared plus 2.5 squared. That's that little x2 symbol, right? That's how you square it. Equal that out. All of a sudden, you're going to get 21.46 centimeters is equal to c squared. Now, common mistake number 3 is people think that they're done here. You're not. You're not finding c squared. You're finding just the c, right? So
divided by 2.
So we don't divide it by 2, but I like where your head's going with that. So we need to turn this c. We need to turn the c squared into a c. So whenever we're dealing with exponents, so this is where I'm going back to this little sheet here. I'm going back to these little squares here. Here we go. So like we know that this is 5, right? So we need to take what's called the square root of this. So that's how we're going to figure this out. The square root of this 9, of this 16, of this 25 is going to give us 3, 4, and 5 respectively. The square root, when we square something, you're turning the number, which is 3, right? That's what this is. But I'm going to highlight that in red, actually. So 3 is this line here I'm kind of scribbling in, right? That's the length of that side. When you square that, you're making this squared, right? You're taking this and you're filling this in. So we understand what squared is, like at least like a picture. When you take the square root of it, you're taking that square, you're just trying to figure out the length of one of those sides of it. So, ooh, that's not what I need. So if I want to find the square root of this, what I need to do is I need to press this little button here. Right here, where my mouse is. So if you press this button, you should end up with this on your calculator. It should almost look like a half of a square. And then you just put that in. It's 21.46. Oops.
Well, could you just put it with the answer? No?
Sorry?
Like 21.46 in that, or
Oh, so good question. So first off, I'll put the answer here, then I'll go into that, okay? That's a good question. So I take my square root of 21.46. That's what that means, right? So what I did was I took the square root of this.
So we can do that.
and all of a sudden I get 4.63 centimeters. Again, so what that means is if I were to take a line, which is 4.363 centimeters, and if I were to square that number, right, just like how we had those blocks before, just like how we had those previous blocks, if I were to square that and you counted all the squares, you'd get 21.46 square centimeters. So finding the square root of something is just finding the length of one of those sides. So now I want to go into Kim's question because it was really, really good. It's about the calculator. Well, can't I? So, so I'll show you what you did to get there. So first up, if you just write 21.46, you take the square root of that, it breaks.
No, it didn't.
Oh, you're right, it didn't for you. And so I'll explain why. So I did it with a fresh calculator. I did this little on C button, and then I put it in there, and then it broke. But what you did, Kimberly, is you did this. You did the calculation, right? You did 3.9 squared. You added 2.5 squared, and you pressed equals. When you have this big number here on the bottom right, your calculator's smart. It knows you want to do something with this number. So when you press square root now, it's assuming that that number that was here is going in the answer there. And then you just press equal. Right? You didn't type anything. It just assumes you want your answer there. So it worked in that case. So if you're doing it how you would do it, which, you just do 3.9 squared plus 2.5 squared, then you take the square root of it. That will work. That will work. But if you press the on button here, you're going to break it. So it's one of those weird things with the calculator where we just need to pay attention with how we do it. But okay, so in this case, maybe you didn't. Well, then your calculator will just give you an error. But so in this case, I figured out C, which is 4.63 centimeters. Cool. I found the length of my hypotenuse. I'm done. We're going to skip question B here. We're going to come back to that in a bit. For now, what I want you to do, I want you to do question 1, but I only want you to do the first part, which is Pythagorean theorem. I only want you to find the hypotenuse for question 1.
Well, what is that?
What's the hypotenuse? Well, what's the Pythagoras theorem? That is this thing here.
Well, we don't have to do it like now.
Sorry?
This last example.
Yeah, so just like what we did, I want you to practice that now. That's going to be on page 15. On page 15. So just do question 1 and only do the length of H. Leave a little bit of room if you can. So I'll give you like 5 minutes for that. Then I'll quickly whip through those. Pause. So I've just put the first one up there just to kind of check your work while you keep going. I'll give you another like 3 more minutes, but you can just check your first question there and see how you did. So the definition of the tangent ratio now might not make a lot of sense, at least from the words of it. We'll go through it just kind of how we did with this thing. So what we're going to be putting here is, so tangent ratio. So now it's something called like trigonometry. So you guys might have seen something like this before. Why am I penciling it? I can literally write it. You might have seen something like this before, like SOHCAHTOA. That's used for like trigonometry stuff. The tangent one is only this one, and I'll explain what this means in a second. No. So you don't have to write that down, but you'll be writing down what I'm about to do next. So with the tangent, that's only one of those 3 things. So the tangent ratio is, so the slope. We use the tangent ratio to find either a missing side or a missing angle, we either use the sides to find a missing angle, or we use an angle and a side to find another side. So tangents basically using angles of triangles now. So what we do to find an angle of a triangle, if we're trying to find an angle of a triangle, we can use the tangent ratio for this. And we do this, by using, the slope of a line. And remember, the slope is rise over run, right? So we use the slope, which is rise over run. Which is the tangent opposite over adjacent. Oh, there we go. Which is the opposite over adjacent of the angle of elevation. So let's break that down. I'll let you write it down, and we'll break it down. Give you a second more. Okay, so if we were to turn this into English, this is basically saying we take the slope of a line and we use that to find an angle. We're using the slope to find an angle. That's what this is saying, just in much fancier terms. So let's say, for example, I want to, don't write this down. Let's say I wanted you to find, hey, what's the angle of this, of angle B? What is that? You would use two sides to figure that out. That's what tangent is. So how we can do that is, so below that, so how we can do that, when you know the tangent ratio, that's the fancy way of saying slope. So you want to write this down now. So when you know the tangent ratio, which is the slope, you can use the inverse tangent function. Again, a lot of words, we'll explain what that is.
Did you say right this time?
Yeah, yeah.
Okay.
I just need to draw something in here. You want to leave a little bit of space between this and grade if you can, by the way. There'll be something else we'll have to add later. Probably tomorrow, maybe tomorrow. Okay, we'll turn this into English in a second. Everyone got that written down?
Is that 2 or 3?
Right here?
Yeah.
This is a -1.
Oh, there's 1?
Yeah, so this is 10. There's a little -1 there in the power part. And then this little symbol here is I'll draw a little bit bigger. That little symbol here is this. This thing here?
It's like a little Pokemon.
The one on the left side? That little, is that an arrow or is that?
This?
Yeah.
That is a -1.
Oh.
-1, yeah. So this is tangent to the power of -1. And then I'll explain what this is in a second. But there's a bracket, this little weird circle Pokeball thing, bracket. And all of this is in another bracket. Okay. So this little circle thing, what the heck is this? This is something called theta. That's what the math people use it. That's what math people call it. This is the fancy way of saying an angle. This symbol means an angle. Do you remember how so sometimes we use like X to find a number, right? To represent a number. That's the same thing, just an angle instead. A lot of people, sometimes you'll see people use an X in here as well. That's okay too. It's just a symbol to represent, hey, there's supposed to be an angle in here. So what we know is we know that tangent of theta, so tangent bracket theta bracket is equal to it's equal to opposite. I'm just putting OPP over adjacent, ADJ. Again, mathematicians are lazy. We're just writing it like that to save some space. But so this is the actual formula of it. So when you see that SOHCAHTOA thing, that TOA is tangent is equal to opposite over adjacent. That's what that's shorthand for. So let me just erase that. Cool. So let's jump into this and show what the heck this actually is. Because right now, this is probably it's confusing words, right? This is not well worded. It doesn't make much sense outside of math, right? I always say, take the math, turn it to English. We're using the slope to find the angle. And we do this with some mathematical stuff, the tangent. So I'm gonna zoom on down to page 13 again. So there's this question B. Find the measure of angle A. I'm recording, right? Good, okay. So on page 13 on question B, so we're coming back to this now. So we already know how to find the sides of the triangles. Now we need to know how to find the angles of the triangles. And we use this right now by using the tangent function. And so we want to find the measure of angle A. That's this thing here, right? That's the measure. So we're trying to find this angle here. There's a little invisible theta here. That's a little too big. I'm going to make that small. Thinner. There's a little tiny theta symbol here, right? That's what we're trying to find. We're trying to find the angle of that. This is an angle of elevation. What the heck's an angle of elevation? You're looking up. When you're elevated, it's looking up. That's what it is. This is, imagine you're standing on the ground, you're looking up at a cliff. This is a cliff right here. You're over here. That's an angle of elevation. You're trying to see how the heck high is that cliff.
Did you say Medina last night? Sorry, that's your
I'll answer that in a bit. Yeah, I don't want to get too derailed. So, this is what I want to find. How am I going to find this? Okay, well, I'm using, all I know is I know sides of this triangle. I don't know the angles. Okay, I can use side. I need to use sides to find the angle. Oh, that's tangent. So I'm going to quickly write down my formula here. Tangent of theta is equal to what? Don't tell me the numbers. Opposite over adjacent, right? So TOA. TOA, opposite adjacent. Frankly, you could just put O over A here. That's fine too. This entire thing is just a way of shorthand. So, oops, here we go. So we talked already how to find a hypotenuse. We know how to find an hypotenuse. It's opposite of the right angle. But we need the opposite side and the adjacent side of this triangle. So how you can find this, first off, we know how to find hypotenuse. The opposite is going to be opposite of the angle you're using here, right? So Aiden, what's going to be my opposite length here I'm going to use of these three? 2.5. 2.5, right? I'm going to use, actually, I'm going to write down here. I'm going to use 2.5 centimeters. Is that big enough text, by the way? So it's opposite because it's opposite of my angle, right? So I'm just going to write that here just so we have that as a reference. But I take my angle, I look at what's opposite of that, what that is facing. It's facing the cliff wall right here. Right? This is my opposite side. So now there's only three things of a triangle. There's the opposite, there's the hypotenuse, there's the adjacent. We know what the hypotenuse is. We know what the opposite is. That means one side, there's only one side left. There's only adjacent left. Which side is going to be adjacent then?
I mean, this side.
The bottom? Line AC?
Beside it?
Sorry?
The one beside it?
Not the one beside it. So what this?
Opposite.
Well, this is my opposite, right?
Yeah.
This is my hypotenuse, right?
Yeah.
So what does this have to be then?
3.9.
Which is the adjacent side.
Yeah, that's what I said. I just didn't.
Yeah, line AC, like 3.9. So this whole thing is 3.9 centimeters.
That is dividing by that?
So not quite. So 2.5 centimeters divided by 3.9 centimeters, that is not going to give me an angle. If you do that, you'll get like a 1 point something. This is not the angle. We need to use a special calculator thing to be able to get there. So tangent actually means something on your calculator. It's like a hidden weird like formula within your calculator. So how I can figure this out is, so if you have your calculator here, right? The whole point of equations is you're trying to get something by itself. I'm trying to get theta by itself. Theta equals, boom, something there. There's an answer there. But there's one thing that's a problem, right? It's this little tangent. This is the problem. Normally, I would just divide.
So do you have to multiply?
I'll get there. I'll get there. Normally, I would just divide by tangent. If this was anything else, if this was like a 5, you would just divide by 5, boom. This is by itself. You have your answer. But if you try and put this in your calculator, if you try and do my little fraction button, 2.5 and 3.9, and I take this whole thing and I divide it by, my tangent button's right here, right? On my calculator, right here. Everyone seeing this? Everyone sees the tan button? If you try and do this, it breaks. So you can't do it. So there's a special way to do it in your calculator. That's technically what we're doing. We are taking tangent. We're taking this side. We're going to divide tangent from both sides. This is going to get canceled out. We're just left with theta equals an answer. So how I do this, put your fraction in there again. 2.5 over 3.9. Press your equal sign, right? Now we have an answer. Our calculator remembers that there's something important here. So 2.5 divided by 3.9. So if I want to divide by tangent, we do this. If you look above your tangent, you see a little tan to the power of -1. Oh, that looks familiar. We wrote that down 5 minutes ago. So to get to that, you don't press the tan button. You see how it's for you guys, it's going to be orange, right? For me, it's red. To access that, you press this little thing up here on the top left. Second function, second F. the same color. So take second F. I'm going to press tangent now because now that's telling your calculator.
Well, how did you get 2.5? I did get that.
I just pressed equals. 2.5 over 3.9, I pressed equals.
No, I mean, like, how did you put it over?
I'll show you in a second.
Sorry.
Yeah. So I take my second F, I press tangent. Equals. Again, I press equals, that brings your answer in there, right? All of a sudden, this gives me an answer. This is now my angle. It is 32.66 degrees. So go back to red. So 36.6, to say 32. So it's 32.66, not centimeters, degrees. That little red circle here, that means degrees, right? So I'll punch that through my calculator again, but does that make sense? Like why we're using that thing now? If you're trying to divide by a tangent, you can't just do it on your calculator. That's where we have to use that special like symbol there. And I like going into like the meaning behind it. So I'm going to quickly whip this in my calculator again, just to show you just in case. So what I did there, Kim, was I pressed this little button here, right? That's the fraction button. Then I put my stuff in. So 2.5, 3.9. It equaled that out. Again, the equal is very important there because it makes your calculator remember. And then I took that second function, took the second.
Could we have just done that?
No, if you do 2.5 divided by 3.9, you'll get like 0 point something.
No, not that, like, 25.
Well, no, it won't work. It won't work. You have to do it this way.
Put the tan after, and
You-
then equal?
So you do the 2.5 on the top, 3.9 on the bottom. So equal that out. And then what you do is, so you have this here, right?
Yeah.
Okay, and so then take your second function and then press your tan button and you'll get this little tan to the power of -1 thing here. Yeah, and then press equals and then you get your answer there.
So it's degrees because it's an angle, right?
And yeah, and then it's degrees because it's an angle, you betcha. So once most students get to like trigonometry, it gets really like hard to understand it, right? Like tangent's one of those things we don't really understand very well. But I want to specifically go in and talk about why it is this. How come we're taking this and we're technically putting our little fraction, our opposite and our adjacent here. That's what this is. So you could also take the second, tangent to the power of -1, the inverse of tangent, that's what that's called. Technically, over 2.5 over 3.9. This also works. That's technically what's happening. Remember, there's a little invisible multiplication symbol in here, right? But that doesn't make much sense because I just said we're divided by tangent. This is not divided. This is a little multiplying symbol here. What the heck happened here? That little -1, take any number. If I take 2, there's a little symbol here on your calculator, this thing here, second function, that raises to the power of -1, right? I get 1 over 2. What that little negative symbol does, so again, if you take 2 to the power of -1, what it's actually going to do is it's going to take what's called the inverse of it. It's going to flip it. Because remember, there's technically a little invisible 1 here, right? This is 2. If you just take 2, there's a little invisible over 1 there. We're just really lazy mathematicians. Anything to the power of -1 is just flipped. So that's what's happening here. They took tangent and instead of, and what they do is they just say, okay, well, if you're dividing this, you're flipping it, right? This is technically going to be like 1 over tangent. Calculator breaks when you do that. So instead, it just turns it into this. You don't need to write this down, by the way. So that's just how your calculator like makes sense of it. So that's why, even though I said we're dividing, it's technically multiplying the thing. So let me just erase some of this stuff. Okay. Okay, so let's do question 2 here together. So for question 2, what most people are going to think about doing here is they're going to think, oh, okay, I need to find the hypotenuse, right? It says hypotenuse. I need to do Pythagoras theorem. No. Read the question very carefully. It wants you to use the slope of the hypotenuse of this line as a fraction. My slope is my rise over run. What's my rise here? Okay, what's my rise of that triangle? 6.8, you betcha, right? That's going up, right? So it's 6.8 over 4.2. Right, okay, I found my slope. I found my slope of this line here. Steven, just make sure you're writing that down.
So like, when you're writing it, you don't put capital R or anything, or it just has to be lowercase.
Like this R here?
Yeah.
That one, in this case, it won't matter. Yeah. Sometimes it does, but in this case, it doesn't. But so all I did was, I don't need to find my hypotenuse. It asked me to find the slope of it. So this one's a lot less work. Just slope is rise over run. Okay, cool. Step 1, I've done that. The next thing it's asking me is use that slope to find the angle of elevation. Now, if you look at your diagram, it tells you that angle already. It gives you that little theta symbol here, right? So I then know I need to use this. So all of a sudden, I now need to use sides of triangles to find an angle. What do I use? What math tool do I have to do that? Oh, so I'm using sides. All I know on this triangle is sides. So I'm using sides to find an angle.
An angle?
I'm using my trigonometry, my tangent, right? Because if I'm finding sides, I can use Pythagoras. But because I'm finding angles, I need to use this tangent thing here.
Oh, sure.
Yeah. So again, whenever you're looking at a question, it's asking you to find an angle, you're using trigonometry, using that tangent, okay? That tends to be a thing a lot of students struggle with is they know how to do it if I say find the tangent. It's when you apply it in a word problem that it all falls apart. Okay, so I now know I'm using my tangent, right? Tangent of theta, that's the angle, is equal to, what's it equal to, Austin? Tangent's equal to?
What is the word again?
Opposite and adjacent?
Yeah.
Yeah. Okay, tangent equal to opposite and adjacent. I know this is my hypotenuse because this is opposite of my right angle, right? Which of my two sides is going to be my opposite here? Which of these two sides is the opposite side?
Of what?
6.8, you betcha, right? Because it's opposite of my angle.
I didn't know it's not the angle of it.
This one? Oh, so yeah, 6.
Oh, shit, I just seen that little circle.
Oh yeah, the little circle, right? So it's really important to pick, so the details matter now in the question. So 6.8 over 4.2, right? Because 4.2 has to be my adjacent because now I have a hypotenuse, I have an opposite. So this is the only side left. Okay. So practice punch that in your calculators right here. I'll put the answer up there in a second.
would it be the 23 or?
Ooh, we'll find out. Okay, so I'm moving my calculator over. So remember, you can just do it this way too now if you want. I just wanted to show you how that works. But so it's my inverse of tangent, right? That's that little negative sign means there. The inverse of my opposite and adjacent. That's what this reads. If I press equals there, 58.3, 58.3. 58.3 degrees. That sounds about right. Like, right? That seems like an acceptable answer, just like looking at it. So I'm going to show you. So first off, this is the right answer here. 58.3. Yep, that's right. I'm going to show you a really common mistake people make, which is they take that, that's 6.8 divided by 4.2. So they take this, but they don't do the inverse of tangent. They don't do that little negative symbol there. If you do this, you're going to get some really weird answer. That does not seem right. That means you have an angle of 0.028 degrees. That is basically a flat line, right? That is tiny. So if the second you get something like that, you know you've done something wrong in the calculator. Okay, so that makes some kind of sense here at least.
Yeah.
The trigonometry is where it usually kind of falls apart for a lot of students. So that's why I really want to make sure you know when you use it. You use it when you're trying to find angles. You use Pythagoras when you're finding sides. That is the difference between these two things. Okay, I want you to go now. Now I want you to go back to question 1. I want you to now find the angles of these. If you don't have room on here, just do it on your whiteboard or a scrap piece of paper or something. Just find the angles now of these.
Where do you want, where's the thetas gonna be?
Ooh, really great question. We're going to do the angle of elevation here in this case. In this case, so I'll kind of give you a hint here. Angle of elevation you're looking up for question A, it's going to be this one here. Again, imagine you're staring at a cliff. You look up, oh, there's the entire cliff face here, right? So this is my angle for A. For B, it's this one. And then for C, it's going to be this one over here. So just make sure you do a quick note of those on your 3 triangles. This is on page 15. And if you finish this, you can start working on question 2. But so I'll give you a couple minutes for that, guys. Only a couple of minutes, yes. Oh, pause my recording. Okay, so you should find the answers here now. For B and C, I only did it to 1 decimal place because that's what Past Me wrote down. So if you've gotten to 46.4, you're close enough then.
What you got that? Oh shit. Is that the?
Yeah, so it's these, yeah, so this is the answer here, 23.84 degrees. So I took my,
thought it was this side and that side.
like you thought it was this side first? So
Yeah.
oh, I see. So remember, so the opposite side is going to be opposite of the angle here.
Well, yeah, I did that, but I didn't know that adjacent side would be like.
Oh yeah, so you can always find your opposite and your hypotenuse, and the last side remaining is going to be the adjacent side here, which is the 4.3 in this case.
Well, listen, okay, what about B?
For B, so your opposite side is, so here's my angle, right? So my opposite side is going to be 7.8. So O, and then my 8.2 is my adjacent.
And that's 46.4.
46.4, yeah. Yeah, when you take the inverse tangent of that, yes.
I see.
And then for question C, my opposite angle in this case, my opposite is going to be the 6.5. This is my hypotenuse here, that's 11.43, which means this has to be,
I had a different number than
You might have, did you do the 8.2 divided by 7.8
I didn't divide it, I put 7.8 over 8.2 with the tangent,
with the tangent?
the inverse. I got 43.57.
43.5. We'll take a look in a second there. I'll come take a look in a bit then, okay?
That's it.
So you did so this would be the second. So you take your inverse tangent of 7.8 and 8.2.
Yeah.
What the heck?
I told you.
What's going? Oh, I gave you guys, oh, you know what? You're right. I gave you guys the wrong angle here. Sorry. You're right. You're right. Okay, if you got the 43,
Give us the right angle,
Yeah.
you got the wrong answer.
yeah, I know I gave you the wrong angle.
Oh.
Yeah, it was supposed to be over. Yeah, okay, I gave you the wrong angle. You're right. You're right. Yeah. Yeah, and this one's the right angle. Apologies about that. Because you're facing the cliff wall from this side.
Okay, how did you get C?
How did I get C?
Yeah.
I took my opposite, so my 6.5 over the 9.4.
Um,
Oop. So 6.5 over the 9.4.
okay,
Oh,
so.
did I give you the wrong one too? What the heck's going on? Okay. Sorry, I've given you the wrong angles apparently. My bad. Or past me did it wrong and my answers are wrong. So this one's 34.66.
Okay, good.
Okay.
I thought I was.
Nope. Sorry about that. I think past me may have made a mistake. Okay. So for the most part, that's what like the core of like this lesson is. It's based on tangent and Pythagoras. There's just a couple of other little small things we can do with those answers here, which are grade and pitch. These are a couple of different things, different ways we express this. It's the same stuff. It's just different ways that people in the real world use it for different things. So is it for grade? Has anyone here ever driven through Banff to Jasper?
Just about.
Just anyone have to really go through like really like steep like drive through the mountains before we have to go like really steep roads? So if you've done that, you've probably seen some type of a sign that said something along the lines of like, you know, the grade is, I think it's in like a triangular sign here. You know, they might say something like this. You might have, you might not all of them do it. But what this basically means, this is telling you how steep something is. How steep a road is usually what grade is used for. Now, thankfully, we're in Saskatchewan, which is relatively flat. But if you ever drive through any like really steep mountains, you're going to see these signs usually pretty much everywhere. And this just tells you how steep the road is. Because if you're driving down a really steep road, you're slamming on your brakes the whole freaking time, right? For you in a little car, that doesn't matter as much. But for people, but if you're driving a semi, for example, or a large truck, or you're bringing a heavy load, that grade means something. That tells you you can go down this road or you can't. So they calculate this grade using math actually. And so what the grade here is, so we're back on page 12. We're back on page 12. So the grade is, there's going to be two things you're going to write here. So you'll have to write small. I do apologize. I didn't give you guys enough space. So the grade is, so a grade is the slope of a road or any other surface. Steven, you getting this? Yeah. So it's the slope of a road or any other surface expressed as a percentage. So if you're on a really steep road, they use it as a percentage. So if you're on like a like a 7% steep road. Doesn't sound like a lot. That is terrifying.
You know, Savannah's pregnant.
I did not know that.
Oh, her dad was last night.
For which?
Her dad,
Oh, he shared the news?
yeah.
Hopefully not an unwelcome surprise. That's good. I hope that all goes well for her. Okay, so that's what a grade is. It's the slope of a road. They say it as a percentage. That's what it is. Now, how we figure it out in math, if we want to turn, so to turn a slope to, it's called a percent grade. I'm just going to put the little symbol here to a percent grade. That's what that means. Multiply it by 100. So to turn a slope to a percent grade, we multiply it by 100. So that's one thing. So if we want to turn a slope into a percent grade, we multiply it by 100. To turn an angle of elevation, so to turn an angle to a percent grade, you use the tangent of theta of the angle times 100. So we take the tangent of the angle, not the inverse, just the regular tangent now, and times it by 100. So there's technically two things here. There's using a slope and there's using an angle, and both of them are to find, it's called the percent grade. So I'll give you a second. Okay. Everyone good? Oh, okay. I'll give you another minute.
So we'll have to invert the tangent again?
In this case, no.
Okay.
Yeah. Austin, you good?
Yeah.
Okay, cool. So I want to go down to question 3 here now. So question 3. So if you're driving a truck on the Canadian highway, there's a sign indicating a 7% grade. So again, you're going to see a sign that probably looks like this. You know, it says grade up here, blah, 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 7%. That's what he sees. He sees a sign that says grade 7%. So first off, we want to find what the slope of that road is as a fraction. So slope of that road as a fraction. You're right. That's exactly it. 7 over 100, right? 7%, right? Percent. percent. Cent means 100, right? Takes 100 pennies, 100 cents to get $1. So this means something, I'm gonna put X there, over 100. So 7% is 7 over 100. Makes sense how I got that, right? Cool, okay, that's my slope. So rise over run. So this means for every 7 meters, so rise over run. So the road goes 7 meters higher for every 100 meters you drive forward. So it's going to look something like this. You're going up something like this, which doesn't sound scary, but that's a lot. that's a really steep road. Cool. That's it. That's literally question. That's A. 7 over 100. That's it. Done. So now what we want to do is we want to find the angle of the elevation of the road. So word problems usually mess with people. You can make it a heck of a lot easier for yourself if you draw yourself a lovely triangle. So I have my lovely little car here. You don't need to drive the car. Don't worry about that. You do not need to drive this car. Oh my gosh, this is an awful car. Screw it. This is a car, right? we'll take it. This is a car.
So do you put 10, 7?
I'll get there. I'll get there. So draw yourself a lovely little triangle if you're ever unsure. So this is what he's driving on. He's driving up this little slope here, this little line here. And it goes up 7 for every 100 meters or 100 something. We don't actually know. They didn't give us a unit of measurement here, but it goes up by 7 for every 100. It goes forward. So I want to find this angle here, right? This is the angle of elevation, isn't it? I'm driving into that cliff wall. So you're so to find an angle of elevation, so to find an angle of elevation. Yeah, so we're using sides to find angles. You're right, Kim. We're gonna use tangent. So I take my tangent of theta, tangent of my angle.
And you put 7 times 100.
Equals opposite over adjacent, and you bet. So equals 7 over 100, you betcha. So I punch it in my calculator. Remember, I'm gonna have to divide by this little tangent, which means I need to take the inverse of it.
Well, it's like 40.
So this case, yes, it is 4 degrees in this case. And doesn't that kind of make some sense? Because if you're driving like a 4-degree road, that sounds okay. If you got 45 degrees there, your car is not staying on the road in this case. So you're going to get a really small angle when it comes to usually grades like this. Yeah, in this case, it's just 4 degrees. That's it. That's the answer. So I'm using sides to find an angle. Oh, okay, that has to be tangent then. That's what it has to be. I'm just going to scroll down for one quick second. Okay.
Draw the car too.
You know, you don't have to draw the car. No, I just wanted to show you how I got that.
Skateboard.
It's not a good. Oh my gosh, that is a skateboard, isn't it? Yeah, it's not a good drawing at the slightest. You saw my art yesterday. Like I said, I'm worse now.
You spelled like better than that.
I really did, right? I was 6. Okay, so that's that. I got one more example here that we can work on. You good, Austin, or you good? Okay. So there's one last thing here, which is something called pitch. I know I'm throwing a lot of stuff at you. It all comes back to angles and sides at the end of the day of triangles. But there's something else called pitch here. And so what pitch is, so this is on page 12. So a pitch is the slope of a roof. A pitch, thank you. So a pitch is the slope of a roof. If you have a house, it has a roof, the steepness of it is the pitch. So a pitch is the slope of a roof. Make sure you leave a little bit of space on this right side. So I want you to leave a little bit of space on this right side because you're going to be drawing something in a second. So it is expressed as number of inches of rise for every 12 inches of run. So example, a roof that rises 6 inches. That's that little sign there, 6 inches. I'm just going to put inches there. So a roof that rises 6 inches every 12 inches. Oh, darn it. Would be, I'll move that in a second. Here we go. Oh gosh, that's not what I meant to do.
Ratio.
It is expressed as a ratio, you betcha. So kind of hard to wrap our head around that. That was why we want a little bit of leftover side here. You're going to be referring back to this. I promise you, you're going to be flipping back to this. Which way was it again? Remember, it's always rise, overrun. Rise, overrun. Rise is 6 inches, 6 inches on the left. Rise, overrun. This is the same thing. So again, draw yourself a lovely little, what did I do here? Draw yourself, we have our, I'm just doing, this is half a roof of a house, right? All I've done is I've taken, oh gosh, that is awful. Let me do this. You do not need to draw the house. All I've done is I have taken the area I'm drawing in blue and I've enlarged it to make that little triangle here. So this blue stuff I'm doing down here is this little triangle here, okay? That's what that is. You do not need to draw the house. I just want you to understand why I drew a triangle here. So if this is a roof, right? This is half of a roof right here, what I have on the triangle there. This is saying for every 6 inches it rises up, it goes 12 across. That's all it's saying. It's a 6 to 12 ratio here. The stuff I'm circling in blue, this is how you would express it. So it makes sense like this, but when we throw in a word problem, people's brains tend to turn to mush a little bit. The angle of elevation would be this corner. Yeah, would be this corner. Yeah, thank you. I forgot to draw my little right triangle symbol there. Okay, so that's what pitch is. So it's just the slope of the roof. So the pitch is going to be this thing right here. It's this side right here. This is the pitch of the roof. It's the slope of it. We just expressed it in that weird ratio thing, but that's what it's actually measuring. So let's turn this into a math problem. I'll give you a second to write it down. Am I recording? Yes. Okay, everyone good? No one's saying no. Okay, so I'm going to zoom on back down to page 14. So again, we've thrown you a lot of stuff. Let's figure out, is this talking about angles or sides? This is going to tell us what the heck we need. So how wide is the shed in the diagram below? If the pitch of the left side, so the left side, that's the blue stuff, that's this thing here, right? Is 3 to 4. And the pitch of the right side, let's do orange, is 8 to 9. Okay. So it's talking just about lengths of stuff. It's just talking about lengths in this case. So it wants to know, but overall, the main question it's asking us though, is how wide is the shed? This thing here, this line at the very bottom. How wide is the shed? Well, the shed is 3.2 meters plus L meters wide. We just don't know what L is. That's what it's asking us. So we need to, what we're trying to do is we're trying to figure out this, right? If we know how big that is, I know how wide the shed is. I just have to add those two numbers. But how I'm going to get to that is going to be a little tricky here. So what we're going to have to do, let me scroll down. So let's figure this out here. So in order to figure out how I can use the pitch to figure out the length of everything, I'm going to do the left side first here, actually, because I actually know one of these sides of this triangle. So I'm going to set this up in a way you would have seen on Friday. On the left side, I have a 3 to 4 ratio, right? Rise over run. This is rise over run, technically. 3 to 4 ratio. So it rises 3 for every 4 it goes across. Okay, well, I also know that I have H and 3.2 meters, right? Rise over run. So, okay, we saw this on Friday. All I need to do is I need to take 4 times it by something, and that's going to get me to 3.2. And then I can use that to figure out my answer. So we've done this before. It's just worded a little bit differently. So all I need to do is figure out how many 4s fit into 3.2. So take your number, divide it. Okay. So 0.8 4s fit into 3.2. So 4 times 0.8 got me 3.2, which means 3 times 0.8 is going to give me H. So 0.8 times 3, 2.4. So I now know what H is here. I know the height of this roof, which is 2.4 meters. Does it make sense how I got 2.4? Please say no if you aren't sure. The whole point. No? Okay, no, for sure. So what I did was I set my ratios up here. So I know the left side is a 3 to 4 ratio here. That's the pitch of it. So I just wrote it like that. And then what I also know is I have my rise over run of 2 things I do know, of H and of 3.2. So I set it up that way. So it's just right. All I'm doing is I'm taking 2 ratios. I know 3 of the 4 of them. So I'm figuring out what number I did, what number I took 4 by. 4 times something got me 3.2. I figured out what that something was here. Ooh, how did I get that? Good question. So I took the 3.2 because I know I took 4 times something to get 3.2. I figured out how many 4s fit into it. Normally, when we've done this, we've gotten like a number bigger than 0, right? Or number bigger than 1. In this case, it's smaller than 1 in this case. But so I took 4, I times it by the 0.8 to get 3.2. So I take the 3, times it by that 0.8 to figure out what that H is, which is 2.4 meters.
Okay.
Yeah.
Yeah.
No, for sure. For sure. Like I said, if you guys aren't sure, like, please let me know, right? Okay, so that got me this. Okay, cool. So now what I have, though, if I'm looking at this other triangle here, which is part 2 of this question, the right side of this roof, I now have one side I know, and one side I don't know, but I know the ratio, the pitch of this roof, which means I can set it up that exact same way. So over here, I have the left side. Now let's do the right side. So I know that it is in a 8:9 ratio. It's always rise over run, right? Rise over run. So I know this right side's in an 8:9 ratio. I know it's also in a 2.4 to, that's an L here, right? That's what that is. That's just a little L. I'll zoom in a little bit. So I took 8, I times it by something to get 2.4. Yeah. So yeah, you said 0.3? Yeah, so take your 2.4, divide it by that 8, figure out how many 8s go into 2.4, 0.3. So I took 8, times it by 0.3 to get to 2.4. So how do I figure out what L is, Austin?
Huh?
So how do I figure out what L is then?
You times it by 0.3.
I times the 9s by 0.3, you betcha. So 9 times 0.3 gives me 2.7. 2.7 meters, right? Because it's a period of light. Okay, so now I know how big L is, 2.7 meters. I'm just gonna write that up here, actually. Am I done? No, because what's the question actually asking you for? How wide it is, right?
So you just add them together.
I just add them together, right? 3.2 plus 3.2 meters, sorry. I'm just gonna write that down here. So it's 3.2 meters plus L meters. I now know what that L is. The L is 2.7 meters. So if you add those together, you're gonna get 5.9 meters. Perfect, that's my answer. A lot of people would do all that other stuff, but they wouldn't answer the question. So reading that question is super important. I'll zoom out a bit so you can see everything. Okay. Does that make some sense then on how we use pitch? Pitch is usually the thing that people actually struggle with the most in this case. Don't feel bad about like referring back to how it's used, but it's always rise over run. This is just setting up those ratios we did on Friday. Okay, so we're gonna go for a break here, and then we'll give you guys some time to work here. Okay, so you should be able to go through all of the questions now. What I'm going to do is I will upload a recording of how to do all the questions up to page 19, or most of the questions anyways, just because this is where it's starting to get a little bit more difficult, just because like now we have a couple different tools and it's figuring out which one to use and then using it properly. So I'll upload a recording of how to do that tonight. So if you're unsure on some and you check the answers and it's wrong, you don't know where you went wrong, you'll at least be able to use that as a resource as well. But remember, the answer key is up there as well, so you can check your work as you go through still.